the grand unified theory. So in the previous tutorial, I left you with the idea that we are going to modify the standard model of the Big Bang. Now, the grand unified theory is not the modification, but what this is the underlying physics that leads to the modification. So before we can talk about the modification, we need to talk about the ideas that the modification is based upon. And that's the grand unified theory, or GUT for short. The basis of GUT is the idea that there are four fundamental forces. So essentially, every force is one of these. Even if you've taken physics and you've learned about things like normal force or tension, all of those ultimately come down to one of these fundamental forces. Mostly the electromagnetic force is what you deal with on a day-to-day basis. That and gravity are the ones that you and I interact with the most. The others apply to the nucleus of an atom. So the weakest of our fundamental forces is gravity. We don't think of that as a weak force because we react to it quite a bit, but that's because we're not an atom. If you're an electron or a proton, gravity doesn't have a whole lot of effect on you. And the other forces are much, much stronger. So gravity, we're going to notice it for large objects, but for the vast majority of things in our universe, gravity is pretty minor as far as the strength of a force is concerned. The next strongest is electromagnetism. So this is, for example, what holds atoms together. So, the idea that like charges repel, opposite charges attract. And similarly for magnets, for magnetic poles. And that's why it's combined together as electromagnetism, because they both are connected to each other. This is the one that is responsible for all the forces you feel when you touch something. So all forces of contact ultimately come down to essentially how the electrons interact. So when you touch something, you actually aren't touching it. The electrons in the atoms in your hand are reacting to the repulsion of the electrons in whatever it is you're touching. And that repulsive force we interpret as touch, but we are not actually touching it. Get really, really close, but all those years of siblings bugging each other and saying, I didn't touch her, that they actually didn't. No matter what happened, they actually did not touch. Now, as we go stronger, we're confining ourselves to the nucleus. And the force, the weak nuclear force, this is associated with radioactive decay. and it has to do with the force that actually expels parts of a nucleus and causes that decay to occur and produces some neutrinos, which we talked about last time. Our strongest force is the strong nuclear force. This is what holds a nucleus together. It's very strong, but it only works short range. So it only works in a nucleus. That's why you and I don't typically encounter the strong nuclear force, because we're not the size of a nucleus. But this is a very, very strong force. So that's why the protons and neutrons all hold together in a nucleus. So the grand unified theory has to do with this idea that if you can get temperatures high enough, there's only one force. Now experimentally, we have combined the electromagnetic and the weak nuclear force into one force, the electroweak force. We've done that in a laboratory. And we have combined the electroweak force and the strong nuclear force in a laboratory. The tricky bit is gravity, because all the other forces have some form of both attraction and repulsion. But as far as we know, gravity only attracts. Now, we talked about the accelerating expansion of our universe and dark energy and how that kind of acts like an anti-gravity. But we don't know if that really is the opposite of gravity as we know it. So gravity is kind of a tricky one because of not being broken up into two parts. But the idea is that get things hot enough, even gravity has a repulsive component, and it too then can be combined together into this one superforce. And so that's the grand unified theory. We're going to use this idea to then modify the standard model of the Big Bang.